Several weeks ago, I created a device that measures the temperature in a bottle of water repeatedly over a period of several hours. This video shares what I learned from that experience. This is what the experiment looked like in the end. Conceptually, this device consists of a black jar which has a temperature sensor inside of it. The temperature sensor has a wire coming out of it, and at the end it has 3 leads. There's one power lead for positive power, the negative power lead, and also the data line. And then this is the battery pack. This would be the Arduino and the breadboard. It contains some resistors to make this LED work and also to make this switch work. The purpose of this switch, this button, is to make sure that the experiment only runs after this button has been pushed. Otherwise, what happens is as soon as you plug in the power, the device will begin collecting data, so you can't move it from place to place after you've plugged it in. And this is the Arduino board, and it contains a programmable LED that I use to tell me whenever it collected a data point and when all the data had been collected. The data is stored inside non-volatile memory. It comes from an iButton device. Okay. 跟住我就由呢樣嘢黑色，我用呢樣嘢，呢樣嘢。Okay.
咁梗係由底嗰度影上嚟嘅，如果由個底嗰度游翻上嚟，陣間點游啊
？OK， 咁而家可以停啦。第一層整乾完就咁樣嘅。 裏邊見到仲有一啲窿嘅，所以要油多幾層咯。好啦，而家油完油啦，我而家就要揾方法整到呢樣嘢擺入呢度，又整到啲又唔會流水嘅。好啦，我而家就用呢個glue gun 整呢樣嘢，就係填好呢個窿啊。跟住咧就要揾方法咧度個溫度。This is the experiment running. This green LED it shows whether or not the circuit is running. It's around 2:30. 我而家我就攞返嗰啲資料啦。Now I'm getting the data. So after I upload the program, I can retrieve the data by copying the text from the serial port monitor.記得啊，要插咗個寒水雞先至插電啊！我加咗呢個掣啊！呢次係我第3次整呢個 program 啦。呢次我就揾咗之前嗰幾個 bug 啦，咁我聽日就會再試下做個測驗啦。Around 4:43, 4:43, and the experiment is still running. And now that this LED is flashing, the experiment is complete. So this is the final data from the experiment. As you can see, the readings are fairly smooth. So the temperature profile does not change a lot in between readings. The temperatures range from around 23 to 38 degrees Celsius. And these are the readings. So what did I learn from this? I learned that ergonomics and user friendliness is very important to the design of hardware and software, because the first time I tried this experiment, I plugged everything in and then I connected my thermometer to the setup. And the problem with that was that when I powered on the device, it started running the program right away. However, part of that initialization process, requires that the thermometer is already attached to the Arduino so that it can be initialized properly. But because it didn't happen, I was not able to take data that time. And because the program did not contain any user feedback to tell me that it wasn't running, I wasn't able to know that it wasn't running. And so I ran the experiment for a day and it collected no data. The second time I ran my experiment, I ran into another usability problem, and that was I started collecting data and it would work fine, but after a while it stopped working. And it turned out that this was an obscure software bug, similar to the bug that caused the satellite to crash, because the size of the data structure holding the integer that I was counting was too small, and so the numbers kind of loop around and they don't. My program didn't count properly, and so after a couple of minutes, the number that I was storing for the number of digits became too big for the place where I was storing it, and so it reset to 0 and it stopped working. And so that took me another day to figure out, because I would keep running the experiment. It would work for a few minutes and then it would stop working. And so the lesson from that is that you can't take shortcuts with thinking about the size of the space that you use to store information about time. And you need to troubleshoot more than just a few minutes. You need to actually spend the time, if possible, to run it overnight to see if your software is working properly. The third time I tried my experiment, I succeeded, and it was because I had a button that I could press to start the experiment, and so I could move my device around. It was more user-friendly, and I also had some better user feedback. So for example, I had an LED that would flash when it took a data point, and I also had a different flashing sequence to tell me when the experiment had ended. And so I could check in on my experiment throughout the day to see if it was working or not. And at the end of the day, I would be able to see everything had stopped working and all the data points had been collected. And so I feel that the device, although it can work in theory with just a plug-and-play kind of usability, it's actually better to make things more user-friendly, because during the development of the device, it makes things much easier. I also learned that temperatures, they don't change over a very wide range throughout the day. The temperature kind of behaves in a very predictable manner, and the highest temperature that I reached that day was 38 degrees Celsius. That was the point of my experiment. I wanted to know one day, I one day woke up and I wanted to know how hot the sun could make a jar of water. And the answer is around 38 degrees in Hamilton. It was a bit overcast, so I think I could have gotten something hotter, but I think that was to keep the integrity of the experiment. I have to just take one data point. Well, not really, but I'm not going to do it again. I also learned that I enjoy painting the jar. So when I was painting it out black, I found that experience really enjoyable. And it's actually much harder to do than it seems, because there's always these little holes, and how do you know if you filled in all the holes? And even after I've done 3 coatings, I actually still had about 3 small holes that I didn't notice until I took the experiment apart. So to be able to paint something really well, is actually not that simple, and someone might be able to, or someone probably already has made a lot of money from making a device that paints devices with surety of cover. Also, another thing that might make people a lot of money is if they could invent a device that fits small tubes into larger holes. So during the experiment, there was a part when I had to put the thermometer in and make it watertight using a glue gun. And that was not as easy as I had envisioned. And if someone actually made a device to make it easier to make that hole waterproof, I don't know how they would make it, but maybe there would be some sort of expandable plastic with a hole in it. If someone could make something like that, it could be very useful. And that concludes my my thoughts on this experiment.